by definition, environment means that it includes living and non-living things that an organism interact with or has an effect on it. So living elements that an organism interacts with are known as biotic elements. For example, animals, plants, etc. And then abiotic elements are non-living things, which includes air, water, sunlight. So I have taken this definition from Wikipedia. So it's basically is the interaction between biotic and abiotic. Okay. And by definition, environmental chemistry is the study of the sources, reaction, transport, effects, and fates of chemical species in water, soil, and air environment, and the effect of technology thereon. Okay, so it's basically when a chemical species are emitted into the environment, we need to study where it came from, what reaction it undergoes, how is it transported in the air or in the water or in the soil, its effect to the human or to the organism, living things, and also the fates. What happened to the chemicals when it is emitted to the environment? Some of the chemicals or pollutants, they tend to a few processes that it can undergo. For example, bioaccumulation, biotransportation, and so on. Okay, so we will discuss what happened to the pollutants in the environment, and then the effect of technology. With the advancements of science and technology, okay, so now we have to consider this technology. What can we what he has done so far, the technology to the environment, and now with the in case of knowledge in technology, sustainability, and environmental science and chemistry, what can we do to modify this technology so that it can give less effect to the environment and also to the living organism. Okay. So this is an illustration of the definition of environmental chemistry. For example, this is basic chemical reaction that can occur in the environment. So in this case, we have a sulfur. Okay, sulfur that is emitted from a smokestack, okay, from factories. Okay, now it's emitted into the atmosphere. Sulfur comes from coal burning, okay, and then now it's emitted into the air, to the atmosphere, and then it oxidized to sulfur dioxide. Okay, so sulfur dioxide is considered as air pollutant. It can affect the human respiration, and also it is toxic to plant. Okay, or it's phytotoxic. It's toxic to plant. So in the atmosphere, the sulfur dioxide is then it can react with oxygen and water to produce sulfuric acid. Okay, sulfuric acid is considered as acid rain. Okay, when it react and then it forms in the cloud, when it deposited into the land, it's considered as acid rain because it's very acid. And then when it's deposited into trees, plants, and everything, these are considered as sink. Okay, sink. Okay, it can be either plant or land or human, or it can also be sink into the water. Okay, so now once it enter, okay, the sulfuric acid enters the water system. It can be lakes or sea and so on. So this sulfuric acid will be turned into sulfate. Okay, so this is the reaction that shows from the transformation of chemicals from its source, sulfur, to sulfur dioxide, to sulfuric acid, and then finally sulfate. So even sulfate can undergo, it can recycle back to the, it can be deposited, or it can seep through the water system to underground water. For example, if you have underground water here, then it can seep through to the underground water, and then underground water is consumed back to the human. It is a process where it is affecting the atmosphere, the hydrosphere, and also the lithosphere. Okay. Previously, okay, in the past, there were many environmental problems that are caused by the practices that now we see it as unacceptable. Okay, so for example, this is the old altitude. Okay. This is according to the American chemical industry by a historian in 1954. It says that by sensible definition, any byproduct of a chemical operation for which there is no profitable use is a waste. Okay, so the most convenient, least expensive way of disposing of the said waste is up the chimney or down the river, and is the best method to dispose this waste. Okay, so can you imagine in the 1954, this is what they have been thinking, or the way of thinking is that whatever is a waste, we can eliminate them by disposing it through the chimney and also down to the river. Okay, they say that this is the best way, but now we know it is not the best way. It's actually the worst way. Okay, why? Because now in starting 1970s, they have seen that the effect of this waste being emitted into the environment, and that is when laws and regulation have been implemented to control air pollution and also water pollution. And we can, there have been methods to clean hazardous waste sites. So that's mean that the solid waste and so on, they have been measured. The aim now is to even eliminate the waste at the end pipe. Okay, so now there is a command and control approach using end of pipe treatment measures, and remediation of waste site has reduced major environmental problem. That means that now before we can emit the waste, we have to control the waste. So that now the factory have to implement stack control. They have to do a wastewater treatment before they dispose, and then they have to do remediation for the solid waste and so on. But one thing, disadvantage about this technique is that it's costly and it requires constant surveillance to make sure that the standards are met, and that these have been so that we can reduce the amount of waste emitted into the environment. So this technique has been reducing pollution and has prevented the increase of pollutant release, but is costly and require constant surveillance. Okay, so what now the goal is that we have to close the loop. Okay, so that we must recycle as much as possible, avoid discharge of pollutants, we must avoid, and then apply the principle of industrial ecology, green chemistry, and green engineering. So this is what we are working towards. We have to recycle, we have to create zero discharge, and then material exchange. Material exchange meaning that maybe we can from waste to wealth. I don't know whether you have heard this concept or not. From waste to wealth. Okay, so that whatever waste that is produced from a factory or industry, we must be able to change that into something that is profitable, that can generate income. For example, burning of coal, okay, or coal, okay. So that now how can we generate, or how can we reduce the use of coal in burning to generate energy or to generate heat, okay? Or from agricultural waste, for example, from coconut. Okay, how can we now change whatever waste from a coconut into something that is good? Okay, for example, we can synthesize the material, the waste, into activated carbon, for example, so that now it can be used for wastewater treatment. So that is what my research area, something that is from waste to wealth, from what else? From dietary waste, for example, fishery waste. How can we turn that into something that can generate income? Okay, and then from this is why we want to do this, is that we want to design a more sustainable system. However, it needs proper planning. That is why these concepts are still in a planning stage. Okay.